We're going to start solving systems that are not both linear equations algebraically. So we've done this graphically and saw where the two graphs cross, but there's also a way that you can do this algebraically. So there's a ton of information at the top here. The first thing is called the zero product property, and we have actually used this already. But just to kind of reiterate what it means, it basically says that if you have two numbers being multiplied and the answer is 0, that at least one of those numbers is 0. And if you think about it, if I take like 2 and I multiply it by something and my answer is 0, that something has to be 0. You can't get 0 as your answer if one of the things that you're multiplying isn't 0. So that's the first thing. The second thing is we're going to be solving these systems by substitution. The reason we have to use substitution is because one of our equations will be quadratic and one will be linear, so we wouldn't be able to use elimination because we wouldn't be able to get everything to cancel out because they don't have the same types of terms. You are either going to need to factor or use the quadratic formula in order to be able to solve these equations, and we'll talk about that more when we get there. And then this little star here, some of our equations are going to have more than one solution. So it's going to create a little bit of extra work for us, but just be aware that that's a possibility. It is also possible that we could have no solution, which would mean that if we graphed it, the line on the parabola wouldn't cross. It's also possible that we'll have one solution, or it's possible that we'll have two. So if you want to see a graphic representation of that, you can look back at lesson 9. All right, so let's get to work. This one is set up for substitution because both of them are already set equal to y. And that was one of the things we talked about when we did substitution for linear equations, for linear systems. If they're both already solved for y, substitution is the best way. So what I'm going to do is I'm going to take my quadratic and I'm going to replace the y in the top equation with the quadratic. So it's going to look like this. X squared plus 2x minus 6 equals 5x plus 12. Now it doesn't matter which way you substitute. I like to have my quadratic function on the left because to me it just makes more sense that way, and I think it's going to end up being less work. So at this point, if we wanted to solve a quadratic equation, we would have to get our equation equal to 0. So I'm going to have to do two things. I have to subtract 5x from both sides. I also have to subtract 12 from both sides. So both of these are going to cancel out and give me 0 on the right, which is what I want. Like that's going to be your first major goal, is to get 0 on the right side. On the left side, 2x minus 5x would be negative 3x. And then negative 6 minus 12 would be minus 18. So I am now set up to solve this either by factoring or by quadratic formula. I am going to choose to solve by factoring because it is much, much easier. We are going to have a couple problems where you have to use quadratic formula. So I'd prefer to show you factoring here, and then if you are interested in seeing how to use quadratic formula, you can watch some of the later examples. So in order to factor, we're going to use an easy diamond. I know that it's an easy diamond because my coefficient here is 1. So I put my last number on the top of the diamond, and my bottom number is the middle number from my trinomial. And now I'm looking for two numbers that multiply to negative 18 and add to negative 3. And those two numbers are negative 6 and 3. So what's going to happen now is what's in purple here is going to factor into two parentheses. One of them is x minus 6, the other one is x plus 3. Now here's where the zero product property comes in. I have two things, the two sets of parentheses being multiplied, and they equal 0. That means that either x minus 6 equals 0, or x plus 3 equals 0, or maybe they both equal 0. So we're going to solve each of these. So I would add 6 to both sides, and that gives me x equals 6. Here I'm going to subtract 3 from both sides, and that gives me x equals negative 3. I am not done yet. Right now I have two x values. What I need to do now is figure out what corresponding y values go with each of them. So because I got two x values, that means that this system has two solutions. So I have to do two more things of substitution. Once for x equals 6 and once for x equals negative 3. So what's going to happen here is I'm going to end up with two solutions, And right now what I know is that the first one is going to be 6 comma something, and the second solution will be -3 comma something. So let's figure out what that something is. So I'm going to take x equals 6, and I can plug it into either one of these original equations. The top equation looks like it's going to be a little bit more simple to deal with, so I'm going to choose to use y equals 5x plus 12. So I'm going to say y equals 5x plus 12, but x is 6, so I replaced it. So that turns into 30 plus 12, which is 42. So one of my solutions is the ordered pair 6 comma 42. And I'm going to do the same thing with -3. So 5 times -3 plus 12, which is -15 plus 12, for a grand total of -3. So my other solution is -3, -3. So these two ordered pairs would be your final answers. We're going to solve this system using substitution again. The nice thing about this problem is that I already know that y equals 2, so that's kind of nice. So I'm going to take this expression here, the quadratic expression, and I'm going to substitute it for y in the top equation. So I would have x squared minus 8x plus 18 equals 2. My first objective is always to get the right side equal to 0, so I'll be subtracting 2 from both sides. And I have x squared minus 8x plus 16 equals 0. Now at this point you can either use factoring or quadratic formula to solve. I'm going to choose to factor. This problem is actually a perfect square trinomial, but I'm going to show you by factoring anyway. I need two numbers that multiply to 16 and add to -8, which are -4 and -4. So when you see that you have the same two numbers in your diamond, that means you have a perfect square trinomial. So what I have here is x minus 4 and x minus 4. You could also write that as x minus 4 squared, but I just wanted to show you. So what I would do now is take each of those and set them equal to 0. And then I'm going to solve. So x equals 4, and then this would give us the same answer. So even though I'm technically getting two answers, it's the same answer. So I don't need to do anything twice because they would come out to be the same answer. Now normally I would say we should plug this back into the equation and figure out y. However, we already know that y equals 2. So we are finished. Our final answer is the ordered pair 4, 2. So this is one of those problems, and I'm not going to get too fancy, but if I graph the parabola, it would look like this. And then if I graph a y equals line, that's horizontal. So what would happen is it's going to look like this. So it's going to cross right here. It's like the parabola sits on top of the line. And I know we talked about this before, how it kind of looks like one of those double zeros. And it actually kind of is. That's what these perfect square trinomials generate, is those answers where you technically get two answers, but they're actually the same. So you really have one solution. We're going to do the exact same thing. The previous two problems, our quadratic has been on the bottom of the two equations. So what I like to do, I think I said this in the first slide, I like to have my quadratic expression on the left. So what I'm going to do is I'm going to take this quadratic expression and I'm going to substitute it into the bottom equation. So it really doesn't matter which way you substitute. You can kind of manipulate it so that things work out the way you want them to. So I'm going to write x squared plus x minus 7 equals 3x minus 2. And my objective is, as always, to get 0 on the right side. So I'll be subtracting 3x from both sides, and I will be adding 2 on both sides. So everything on the right cancels out, giving me 0. And then on the left, I would have x squared minus 2x minus 5. Now, if you tried factoring, it would not work because there aren't any numbers that multiply to -5 and add to -2. So in this particular problem, we have to use quadratic formula. So I'm going to write quadratic formula up here at the top, just in case you forgot what it is. And I'm going to identify A, B, and C. Oops. So A is 1, B is -2, and C is -5. So what I'm going to do now is take that information and plug it into the quadratic formula, and it's going to give us our two solutions for x. Now, because this does not factor, we are going to get kind of crazy decimals that we will have to round. So our answers are going to look a little bit messy, but the process is going to be the same. So I'm going to do x equals. Negative b would actually be positive 2 when I simplify that. In the under the radical, I would have negative 2 squared minus 4 times a times c. And that is all over 2 times a, which is 1. So I'm going to do a little bit of simplifying here. This would be positive 2 plus or minus. Inside the radical, it's not really too important to know exactly what that number is, and I'll talk about that more in just a second. But it would be 24 and then over 2. Now I know it doesn't look like it, but this actually represents two answers. And normally when we did quadratic formula before, we would say you had to do a factor tree, you have to get an exact answer, decimals are not acceptable. But because we're looking for ordered pairs, it's going to be easier for us to look at these in terms of decimals than it would with these big crazy radicals. So what I'm going to do is in my calculator, I'm going to do 2 plus the square root of 24 over 2. I'm also going to do 2 minus the square root of 24 over 2. And I want to see what these decimals are. So I'm typing this into my calculator, 2 plus the square root of 24 divided by 2. And I get 3.44948, blah, blah, blah. But I'm going to say that this is 3.4. Okay, so that's as to the 10th is plenty. And now I'm going to do the exact same thing, 2 minus the square root of 24 over 2. And I get negative 1.44948, blah, blah, blah. So again, I'm going to round it to one decimal place, so negative 1.4. Okay, so right away, because I have two x values, this tells me that I'm going to have two solutions. And in order to figure out what those are, we're going to have to plug those in. So we're going to have to plug in x equals 3.4 and x equals negative 1.4. But what I can tell you, down here at the bottom, we're going to have two solutions. One of them is going to be 3.4 comma something, and the other will be negative 1.4 comma something. Now, I can plug these x's into either one of my originals. I think that plugging it into the bottom equation will be the least amount of work. So I'm going to say y equals 3 times x, which I'm replacing with 3.4, minus 2. And that gives me 8.2. So my first solution is 3.4 comma 8.2. Now I have to do the same exact thing with negative 1.4. So I'm going to have y equals 3 times negative 1.4 minus 2. And that gives me negative 6.2. So my other solution is negative 6.2. So these right here are my final answers. They are not exact answers because remember we rounded. But if we were graphing, this would be a lot more useful to have our ordered pairs in decimals versus radicals that you may not know exactly what the numbers are even close to.